Okay, so we're going to talk about today the graph of sine and cosine, and we're going to look at another transformation that we can make. So what I'm going to do is I'm going to use Desmos actually to kind of examine these two different functions. So remember, the graph of sine starts at 0, 0. Now, we're talking about on the unit circle, okay? So when I'm saying that it starts at 0, 0, because it's periodic, it never actually starts anywhere because we're talking about the circular pattern. So when we create the graph of sine, we're talking about our unit circle. This is the first starting point, which is the ordered pair 1, 0. And remember, for sine, we look at the y value. So we're tracking the y value as I move around the circle. It goes from 0 to 1, back to 0, to -1, back to 0. So we're starting at 0, up to 1, back to 0, down to -1, back to 0. And as I continue to go around the circle more times, we're back to 1, then back to 0, then back to -1, then back to 0. So this would be a rotation of 2, there's 1, 2 times around the circle, okay? From 0 to 2 pi, that's a period of 2 pi. It takes 2 pi units to get around the circle one time. Well, 2 pi plus 2 pi is 4 pi, so that's why that's 2 full rotations. If I went the other way, so let's suppose that I went backwards. So I went down around. Well, from 0, I then go to -1, then I go back to 0, then I go to +1, and then I go back to 0. It still is -2 pi to 0, 2 pi units. Okay, so the period is always 2 pi for the graph of sine. For cosine, because I'm taking that same unit circle and I'm going around the circle and I'm using the x values, the x value here is at +1. So when I start at my 0-degree angle, I'm starting at +1. Then my x value is 0. Then my x value is -1. Then my x value is 0 again. Then I end with an x value of 1. So this is one full rotation around the circle. I'm just starting at a different place. So cosine starts at a maximum, then goes to the x-axis, then goes to a minimum, then goes to the x-axis, and ends at a maximum. Whereas sine starts at the x-axis, went to a maximum, goes to the x-axis again, goes to a minimum, and ends at the x-axis. So these are kind of the patterns that sine and the cosine make in the parent function. Okay, so let's take a look at Desmos for a second, where we look at the graph of sine. Now I have a couple of sliders over here, and the purpose of those is just so we can change my my a and my b value. So if we look back, sorry, I'm going to go back. The parent function is y equals sine x, but we can make a transformation where I have a b value that controls the period. That's what we talked about. So this is period control. It controls the period. It isn't the value of the period. It controls the period. This is my horizontal shift. This is my vertical shift. And A has to do with my amplitude. That's my vertical stretch. Okay, so we're going to look at today, we're going to look at these two values. And the function for cosine is the same. Okay, so when I go and look at this, all I'm controlling right now is I am looking at an A value and a B value and trying to kind of manipulate those. So the first is the B value. Remember when I moved my B value and I made it, let's get it to +2. Oops, I wanted it +2. there we go, a b value of 2. So what happens is, I'm going to take my post-it note here, maybe. So if I have a b value of 2, so this is the graph of y equals sine of 2x. Remember, the period is equal to 2 pi over b. So now I have a period of 2 pi over 2, which is just pi. Take a look at your graph. We start at 0, 0, and we have one full rotation at pi radians. So essentially it took what originally was b equals 1, looked like this, and it kind of smushes it together, if you can picture that. So as I increase my b value, I'm smushing the graph together. Picture a slinky. The b value is kind of like a slinky. As you pull it apart, it stretches. As you push it together, the waves or the spirals get closer together. So the b value controls the slinky value. Okay, so you know how I always like to make analogies. So the b value is like a slinky. So think slinky. Okay. Now, the a value is my amplitude. Remember, that's what's going to control the distance from the midline to the maximums and the minimums. So I'm going to go back to a b value of 1. And I bet you there was an easier way to do it. I bet I could just type it. Yep, sure can. But I'm not going to type the code. Okay, so there's my original function. So now look at my a. A is 1. So my graph is only going up to a maximum of 1 and a minimum of -1. Okay, that's because that's the parent function with an a value of 1. But if I shift my a value, so I'm going to take my a and I'm going to increase it. Notice how it gets higher and lower. So now my maximum is at 2 and my minimum is at -2. Notice how I still have the same zeros at 0, pi, and 2 pi. The period did not change because my period b value is still 1, but my a value is 2. So for the graph of y equals 2 sine of 1x, or just x, what that does is it changes the a value and it's a vertical stretch. Okay, so we're thinking it's stretching it out up and down instead of side to side. Okay, so now think about when we had our other functions in our other previous units, like back in November and December when we were looking at all those different parent functions. What happens when I decided to make the a value negative? Well, so if I take the a value negative, that's a reflection, and the same thing is going to happen. So as I go back to a is 1, notice my maximum is at +1. A is 0. Boom, the whole curve flattens. That's because you're taking a value times the function, and if 0 times the function is 0, so we have a horizontal line. So a equals 0 is never going to be our amplitude, because then I don't have a periodic function, I have a linear function. So then I have a, let's go negative, a is -1. So what happens? My still at a 0, 0, but instead of +1, I'm going to -1, and then I'm going to 0, and then I'm going to +1, and then I'm going to 0. So what happens is, for the sine function, when I decide to flip the negative, instead of going up first, I'm actually going down first. Okay, so if I go back to this one note, the graph of y equals negative sine x, or -1 sine x, instead of doing 0, oops, I didn't mean to erase that, 0, I would go to -1, then back to 0, then back to +1, and then back to 0. So it would look something like this, which kind of starts to create a cool pattern. So then I'm going to go down, and then back to 0, and then I'm going to go up, and then back to 0. So it's a reflection of what the original looked like. So instead of x maximum, it's x minimum, x maximum, x. So these two just switch places when I have a less than 0. Okay? With cosine, the same thing is going to happen. So cosine starts at a maximum if I decide to flip and have an a value negative. So a is less than 0. Instead of starting at a maximum, I'm going to start at a minimum. But then I'm still going to come back to 0. I'm going to come to a maximum instead of the minimum, so reflect it. I still have a 0 here, and now I'm at a minimum. So the cosine, when I have a negative amplitude, is looking reverse like this. And we still have that same pattern. Okay, so if we take a look at, and we can illustrate that in Desmo, so if I have my cosine function, notice here is cosine with a negative a value and a cosine with a positive b. So here is my -1, my 0, my 1, my 0, and my -1. So we start at a minimum for one period, okay? And then if I change my b value, kind of smushes it together, right? As the b value gets larger, the graph gets more smushed. As b gets smaller, it starts to stretch out. Now only up until a certain point, because when I get to 0, again, it flattens it out because the whole function goes away. All right? So it starts to stretch, and we can kind of expand the graph a little bit. So when a value is negative, and as it gets more negative, it just stretches more into the negative. As it gets more positive, it stretches into the positive. All right, so we're centered on the x-axis right now, and we're just kind of going up and down. As I shift my b value, it's going to, oops, I want to shift the whole thing over so I can see my x-axis. So as I increase my b value, the graph smushes together horizontally. As I increase my b value back to 1, it gets back to regular at b equals 1. There we go. And there I am back at maximums for my starting value, okay, for cosine.